As you can see, that you should see the next slide on the screen, which gives you a little overview once again of the agenda in this webinar. We'll first talk about resource quota sets. We go into quite a lot of depth, and then a little bit about the QMaster Read Only Threads and sessions, GDI request limits, and then something interesting at the end, which many people probably haven't seen, is a little information on QPING and how it works. So first, resource quota sets. So resource quota sets is a feature that has been in Grid Engine for quite a while. In fact, I believe it was put into the product in 6.2.U5. But there has been certainly a fair amount of confusion about resource quota sets and how to use them. In some cases, it may have not been totally clear on how these different quota sets work together. But as you can see from the slide, the goal of resource quota sets is to manage the upper limits of jobs using resources within the cluster. Now, it's very particular because those quotas are set on running jobs, not pending jobs, so that's an important thing. And resource quota sets can affect different Grid Engine objects. For example, as you can see from the slide, it can affect users, projects, parallel jobs, queues, hosts, and job classes. And so, of course, if you need more information on resource quota sets, you can read the man pages or read the information on SGE resource quota. But for now, we'll just give you a little more detail about resource quota sets and how they work. So, as mentioned, resource quota sets give you the ability to set the maximum resource consumption for any job on any resource. Once you define the resource quota set, then the scheduler uses these resource quota sets to determine from the prioritized list of pending jobs if the next job at the highest priority in that list can be dispatched to run. And of course, if that job exceeds any particular resource quota, then it will not run the job. So only those jobs that do not exceed those resource quotas will be scheduled and run. An interesting thing about resource quota sets is that these limits, these quotas, can be static or dynamic. In fact, you can use an algebraic expression to derive the overall limit value. Now, you define resource quota sets with the qconf command, much like many of the other administrative commands and configuration within Grid Engine. And there are several parameters for a resource quota set. There is the name of it, and this is just a name to refer to the resource quota set. A flag, which tells you whether it is enabled or disabled, so whether this entire resource quota set rule set should be considered. A description of it, which is an arbitrary string to really just give the administrator more detail on what this resource quota set was for. And then there are limits, and those are rules. And each resource quota set has to have at least one limit rule, but of course it can have more. So the limits is where the interesting things happen within resource quota sets, because the rules can contain the following syntax. You can have a wildcard, and that wildcard is not a regular expression, so it's not like what you would expect in, say, grep or some other tool that you use to search for strings. It really just matches all members of a given object. That's what it's for. So when you use, say, for example, that wildcard, the star on the host object, it matches all hosts. That's really what we're trying to get at. There is the logical not operator, which is the exclamation point. And so it matches everything but the given source object. So you can see from the example there, it matches all users who are not in the student's access control list. Quite useful because, you could get into a situation where you may have to define all possible users in your system, so it's much easier to define, say, a blacklist of users and use the not operator. And then quoting. And quoting is quite interesting because it's very powerful. What it does is it treats the object per member instead of all listed members of the object. So as an example, you can see below it's quite obvious what we mean. In that users object, if I use just the star, the wildcard, it means all users together are limited. with the limit rule. If I put it within the parentheses, it means each user is limited to that limit rule. And then finally, I think we mentioned on the previous slide, you can also use an algebraic expression or a weighted sum for host resources. In this case, slots equals a value of number of processors on the machine times 2 plus the number of GPU cards. So you can use expressions to calculate the limits. So limits, as I mentioned sort of 2 slides back, is there are particular objects that it is enforced upon. And we already discussed it with the users through the host objects. And so when you're writing these limit rules, you have to tell the system which source object on which the limit can be enforced. So it could be, I want to limit users. Then there is the mandatory to field, which defines the quota, one or more basically limit definitions. And then these rule sets are similar to firewall configurations. When I show you some examples, it'll make more sense. But really, what happens is you create the object you want to enforce the limit on, the mandatory to word, and then the limit definitions. And that forms a complete rule. And you can have multiple of these rules, one per line. That forms a rule set. And these rule sets work similar to firewall configuration rules, which means that you can have multiple rules within that single resource quota set, but the first one that matches is the one that triggers. And so, of course, it will ignore all the other ones below. Then, of course, you can have multiple resource quota sets. So I could have resource quota set A and resource quota set B, and within each one of those resource quota sets, they can have one or more rules. And in that situation, if there are multiple rule sets, all the rule sets are evaluated and the most restrictive one is taken. We'll see that a little more in the examples here. So here's the very straightforward one. The name, the description, they're quite easy. Enabled, that's quite easy. The first limit rule is limiting the user's object, and in particular, it limits it to one member, Bob. There's the reserved keyword, to, and then the limit specifier, which in this case is slots equals 20. So this is one of the most common ones. Slots are really probably one of the most used limits within a resource quota set. So in this case, Bob can use up to 20 slots. And the next rule is everybody else, which means, as you can see here, each individual user in the user's group is limited to 10. And so that's what that parentheses does. It means that everybody who's in the user's object, every member, is limited to 10. So the next one here, it's the same idea. You have name, you have enabled, and again, you have 2 limit rules. The first one limits the user's object, and it limits all members, each individual member of the user's object to each project to 10 slots. So it's got 2 in there. Not only is it limiting each individual user, but it's also limiting each individual project to 10 slots. And then users, each individual user in the second rule to slots 5, which means that users not requesting a project may run only 5. So you get the idea of how these limit rules work, but you can also see that they're very subtle. You can quite easily create complicated rule sets that could confuse you. So it does take some time to work through exactly what type of rules you would need to solve a particular situation. There are more complicated examples. For example, one that's very common, give exclusive access to users or a user on a host. Name, description are pretty straightforward. Enabled is quite straightforward. Then there are the limit rules. And it limits, again, the user's object. You can see the user's object is quite a common object to use. We're limiting Joe. And then to host crunch 001. So we're limiting also on the host object to crunch 001. To slots equals 16. So it means that user Joe can use 16 slots on that particular host. And then the next one is, again, affecting the user's object, all users, so not individual users, all users, and then affecting the host object on crunch 001 to slots equals 0. So it means that essentially no one else can run on that crunch 001 host. Everyone else cannot run anything. So that's an interesting way to give exclusive access. Slightly non-intuitive, but you get the idea. It does work. Here's another one, which is limiting the maximum number of jobs running on each host depending on the number of cores on each host. It's quite a straightforward one. We'll ignore the name, the description, and the enabled because those are very standard. Again, the limit rule is the interesting one. We're limiting the host object, and we're using limiting each individual member of the host object to slots equal to $number of processors, which is effectively the number of cores in Grid Engine on the machine. So you can see how that works. That host object is going to contain a list of all the hosts in the system, and then when you're applying the parentheses, you're applying the limit to each individual member of that object, which is each individual host, and then you're limiting slots to number of processors, which is number of cores. Now, as you can imagine, you can get quite complicated with these RQS examples. And in some of our customers, they do have multiple resource quota sets with multiple rules within each quota set. So you could end up in a situation with one like this. You're trying to set a minimum and a maximum share for jobs running in the research project in the host group big mem hosts, and assuming in this case there are 100 slots available. So the name, the description, and the enabled are very standard, but you can see there are multiple rules here. In this case, we're limiting projects to the research project, and within the hosts object to all hosts in the host group big mem host to slots 50. So essentially, those people in that research project, they're allowed to get 50 slots on the hosts in that big mem host group. Then the next rule is projects, all projects, and hosts in the big mem host group to slots equals 75. So that's all other projects except research. And the last one is kind of interesting because it's slightly non-intuitive. You're limiting projects, so basically everything that's not a project, so no project requested, and all hosts in the big mem host group to slots equals 0. So if you don't request a project, you can't run a job. If you request a project and it's not the research project, you get up to slot 75. And if you're in the research, you get slots equals 50. So that's how that works. Now, you saw that last example was starting to get quite complicated, and there are potential pitfalls in resource quota sets. Once a rule matches, as I mentioned quite early in this presentation, the other rules are not really evaluated at all anymore. So it's really like a shortcut. Once that rule matches, it just ignores all the rest. And we've seen situations where people create resource quota sets and forget that this is true. So what happens is they're thinking that a particular limit line should be enforced, but the previous line is overriding it. An example in this one, users Joe and Marta are not limited to run only one job requesting the resource MATLAB if they request a project. The first rule expresses that each project can run up to 200 jobs in the system, regardless of what user it is. This rule probably won't work as expected because I think the second rule invalidates part of the first rule. You can get into even more complicated examples of resource quota sets. For instance, you could have 2 or more. And as I mentioned, all are evaluated and the most restrictive one applies. So this first one is limiting the project's object, all individual projects within that project's object to slots equal to 200. So each individual project has a limit of slots equal to 200. And then the second resource quota set rule limits users that are not in the user access control list staff and hosts, all hosts, to slots equal to 10. So users not in staff, ACL, can't run more than 10 jobs in the cluster, even if they request a project. So that first limit rule is quite powerful. And then the second rule in there is limit users, all users, hosts, all users to slots equal 10. And that would be invalidated because that previous rule for users not in the staff access control list limits it to 10. And it's more restrictive, so it is enforced. And so you can see it can get quite tricky. And if you have quite a lot of these rules, you end up in a situation where one of these limit rules is more restrictive and it's further up in the configuration, and it will be enforced over the other limit rule. So that's what happens. To create resource quota sets, as I mentioned, you use the QConf tool. You can add resource quota sets, modify them, delete them. You can also do it from a file, and that's what the capital A and capital M RQS do. To get information about resource quota sets, to see which rules are currently enabled and, which resource quota sets are currently enabled and which rules are triggered, you use the QQuota command. So in there, in this example here, in the match project's resource quota set, the first rule was the one that was triggered, and so now that limit is being enforced, which is slots equals 2 over 2. So that gives you an idea of within each resource quota set which rule is actually being enforced at any given time. That does make it easier to find out which rule within any particular resource quota set is being enforced. And so it does help sort of debug situations where you may end up having resource quota sets trigger that you didn't expect. Now we're moving on to QMaster Read Only Threads. We've talked about this in the past in some of our other presentations, but here in this webinar, we're going to go into a little more detail on QMaster and Read Only Threads and some of the additional functionality around it. So if people have seen our previous Untitled Grid Engine 8.2.0 webinar, you'll realize that we created QMaster Read Only Threads to provide scalability for job queries in big and heavily loaded clusters. And in most cases, these types of queries are QStat and QHost, and they can potentially transfer huge amounts of data, quite a lot more than you expect. And of course, this can affect the QMaster because there is locking going on inside the multi-threaded QMaster to get access to the internal data structures so that, of course, you can display this QStat information. This lock does prevent the QMaster to accept and dispatch jobs while it's happening. So it is quite feasible that if someone is doing massive amounts of QStats or QHosts, then the QMaster does not dispatch jobs, which is, of course, not what you want it to do because the whole goal is for it to dispatch jobs. So we added a new thread pool in QMaster for servicing large numbers of read requests. And this is an optional piece of functionality that you can turn on. And it services all read requests. So before we go into more detail on how you configure it and how you use it, we'll give you some background on what's happening inside the QMaster and why we sort of needed this pool of reader threads. If you've ever looked at what the QMaster is doing in a Grid Engine cluster, you'll see that there are multiple threads because it is multi-threaded, but threads have a specialized role. So the incoming requests are handled by a listener thread. And if that listener thread looks at the incoming request and determines that it is a write request, it queues up that request on one of the worker threads. In 8.2.0, if you've turned on read-only threads, then if it sees it's a read-only request, it will queue it up on one of the reader threads. Now, the main reader threads, right, it'll queue for the reader thread, sorry. The main reader thread gets periodic update from the QMaster on the cluster status data. So that data I mentioned on the previous slide that needed to be locked, that prevented the dispatch, that's the data that the pool of reader threads is getting a periodic update on. And then the reader thread handles the packing and sending the data to the client. And so you can see from this, it's quite obvious that the real benefit is because we're using a snapshot of what is happening inside the internal data structures of the QMaster, there's no locking while that reader thread serves the client requests. Only a little bit while it does its update, and we can control that locking. So we know how it will behave. So how do you configure this? Well, inside the Grid Engine bootstrap file, there is a new parameter for reader threads, and n will represent an integer value. And n can be none, 0, or 2, or more, potentially up to 64. And notice it says in theory because that is the upper limit, but honestly, we've not had a need to ever put it that high. In fact, 2 is the default, and as it mentions in the presentation, that's a safe value. You could also add and delete reader threads at runtime. There is a QConf parameter for adding threads and killing threads. And of course, you give it the thread you want to add or kill, in this case, reader. But when you do it at runtime, those changes are effective until you do a QMaster restart, because it's really, when it restarts, it pulls the configuration from the bootstrap file. So you'd have to change the bootstrap if you wanted to make it permanent. For read-only threads, 2 is the minimum. And in the majority of cases, I don't think we've really seen any more. Right now, 2 is acceptable. You can view the current status of the QMaster threads in the event clients. We've added new command line arguments to QConf to get more information about the reader threads, to get more information about what the event clients are doing within the QMaster. And that's useful information because you can see how many threads are running, what those threads are doing. So some of our customers naturally asked us almost right away. So we saw that you could use 2 QMaster read-only threads, but we saw also that it can be increased up to 64. Do we really need more than 2? Is there a need for more than 2? Well, one way you can find that out is you can monitor the pending read-only requests, basically the reader queue length. And if you're interested in doing this in a 8.2 cluster, you do have to change the global cluster configuration and add to the QMaster parameters the monitor time and set it, in this case, it's about 10 seconds. And what this means is every 10 seconds, it will log information which includes the current length of the reader queue. And it is highlighted here in red, so RQL is 0 in this cluster, which is what we would expect. And if that number continues to stay consistently high, say obviously greater than 0, maybe 1 or 2, then you can add additional read-only threads up to that number. So if it was 2, you could add 2 more. I did mention that all the reader threads are looking at a snapshot of the data, the internal data structures of the QMaster, and that is periodically updated. Well, it's updated not later than after 1,000 milliseconds by default. You could reduce it, but this is our default. Reducing it would definitely increase overhead and very likely reduce performance. So leave it at 1,000 milliseconds unless you experience an issue. Another interesting point is that an update always happens as soon as no read requests are in the reader queue. So when they're essentially sitting idle, it always gets an update because it realizes that it's not doing anything at that time. That's probably a good time to get an update from the QMaster. There are additional threads inside the QMaster which do other activities. One of them, if you looked inside the QMaster using QConf-SE ECL, was showing event client list, you will see the number of worker threads. This is independent of the reader threads. Right now, we set 4 as the worker threads, and it's a good safe value. Probably don't need to change it. You could use 2 worker threads if you're not using any server-side job submission verifiers. And the reason you could lower it is because if you're using server-side job submission verifiers, then one of those threads or more is being used to process the job submission verifier. Now, you may get into a situation where you might need more than 4 worker threads, but that really would only help if you have a server-side job submission verifier that runs too long, for say more than a few milliseconds. And another important thing, you don't need to configure more than 2 listener threads, so there really isn't any need to change that value. And all of this, again, is configured in the Bootstrap file, in the Grid Engine Bootstrap file. Now you're probably wondering, what happens when you use read-only Qmaster threads, or sorry, Qmaster read-only threads? Well, you do get a bump in performance. We have done testing on larger clusters with, as you can see here, not massive cluster, but 153 hosts with 30,000 jobs. They're very short jobs, few-second runtime. And we essentially start enabling the queues once we've got a good backlog of jobs. So we don't basically do it from a cluster that's empty and then have it process. We have a good backlog, let it run. So you get about twice the performance. So the submits are twice as fast, as Qmaster CPU utilization is higher, and the throughput of the system is quite higher too, about twice as fast. And so that's where we came up with this number that I think we mentioned in our Unova Grid Engine 820 webinar, is that you get about 2 times the performance when you turn on read-only Qmaster threads, which is quite good. One other item on read-only Qmaster threads before we move on is sessions. So we added sessions to the read-only thread support because there was a potential situation. We knew it could possibly happen where the reader threads would require synchronization with the main Qmaster thread. I mean, because we are looking at a copy of the data, we might have slightly stale data. And you could see something like this if you were submitting a lot of Q subs and it was quickly followed by a Q stat. You may get a return saying the job is not there. And that's because when that Q stat is being serviced, it's being serviced by a read-only thread. And it didn't quite have an updated snapshot of the internal data structures. So the solution to this is we added a concept of sessions, and they force synchronization. They do slightly slow down the reads to ensure consistency. It means essentially in a session you wait until you get that updated status and then it returns. But it's not typically needed by most users. In fact, we haven't really seen a need for it because things happen so fast. It could potentially happen in a very loaded cluster. And if it does, then you would use sessions. Or it might be useful in a situation where you're writing your own script or tool which does monitoring and you want to be absolutely sure you're seeing the most consistent data. Then you would use a session. Again, sessions are created. You can add sessions using QConf. You can configure sessions. You can modify them. You can destroy them. And you can use them. As you see here, using them, you now have to provide the session identifier when you're using commands like qsub and qstat. And then everything is done in reference to the session. So it does change the overall syntax of Grid Engine commands. So that's why in most cases people don't use them, but it will be useful likely in scripts or in tools that require consistent data. So now we're moving on to GDI request limits. Again, we talked about this a little bit. And GDI is the generic data interface. That's the low-level communications library that is within Grid Engine. And the real motivation behind adding these new request limits is that we recognize that scalability is definitely not infinite. You will always get into a situation where you could swamp the QMaster, even though it is highly multi-threaded and can handle a large number of queries. You could still keep the QMaster very busy. So now you're allowed to create request limit rules for the QMaster, which controls the add, modify, get, and delete calls per second on the API. And it's configurable for quite a lot of objects, but in most cases used for users and hosts. Again, you can configure multiple rules, but they're different. It's different rules evaluation than resource quota set. All the rules are evaluated. Most restrictive rule applies. Different behavior as the resource quota set rule set. You remember the resource quota set, it was the first rule that matched, and it would essentially short circuit all the rest. In this case, it evaluates all, and the most restrictive apply. So there is quite an interesting structure to it. Again, you must specify GDI request limits as a QMaster parameter, and you can have none, which means there are no limits, or you can have a limit rule, followed by a comma, followed by a limit rule, followed by a comma, so you could have it ad infinitum. Each limit rule has a source, followed by a colon, a request type, followed by a colon, an object type, followed by a colon, and then it has the limit, which is user equals max request per second. So the source can be different commands, qact, qalter, qsub, qsh, qlogin. Very likely you'll be using qstat or qsub. They're probably the most common, or even qmod. Then the request type naturally follows from that. So for example, if I was doing a qstat, then the request type would be get. It wouldn't be an add. That wouldn't make sense. Then there's the object type. An object type can be quite a lot of different objects, but it's very likely you'll use things like jobs. So you'll use common ones. Then user can be all users or a particular user name, or host name can be all hosts or particular host name. And then there's the rule, which is the max request per second, which is some integer value. When you put it all together and configure these using qconf-mconf and adding that GDI request limits to the QMaster params, then you can create rules like you see here. This first one limits job submissions for Marta to 5 per second. Whoops, sorry, I clicked incorrectly, on all hosts. This second one limits qstats, all users, all hosts, to 10 per second. This third one limits qhost for all users, all hosts, all users from host UGE master to 2 per second. And the last one limits qstats for Marta to 20 per second. So you can see it's quite flexible. Now we're going to talk a little bit about diagnosing communication using QPIN. There is a lot more in the man pages regarding QPING, so we'll just touch the surface here just a little bit to give you an idea. So really the challenge is to understand in detail the protocol interaction or the communications between QMaster and execution daemons. In some cases you need to know which host did the communication come from, how much data was transferred, what type of transfer is this? Is it a qstat, a qstat, qsub? Where QMon is running? So really this is lower level protocol and communications information about the entire Grid Engine system. You could even get a detailed dump of the communication content. Now naturally that could be very large. And the way we do this is we use a utility called QPING. But you do have to be quite powerful. You must be root on the host where the daemon is running, except if you just want to get status out of QPING. It does add slight overhead to the system because it's getting the data directly from the communications library, but it is not as heavyweight as, say, changing the scheduler profiling or doing more detailed profiling within the QMaster, because we're not actually affecting the QMaster. If you do QPING-info, you'll get some basic information about the communication library status. If you do a QPING-dump and you give it the master host name, so where the QMaster is running, which port it's running on, and then the parameters QMaster1, it spits out more information about the status of the overall communication library and what is connected to the master. You can see it from here. What time, the local connection, the remote connection, the format it is, whether it's binary, if it's a ACK, a NAC. So you're getting some high-level detail of what's going on at the lower level communications protocol level. This can be quite useful to diagnose issues in, say, communications between a QMaster and an exec D. The exec D disappears every now and then. You can see if it, at the lower level, is really just disappearing off of the network, or if something's happening in the protocol within Grid Engine itself. You could also use QPING to get a detailed hex or XML or ASCII dump of the communication. If you do QPING-help, that'll give you more detail about, in particular, how to configure a communication dump. And column 12 outputs the dump in I think hex, XML, and ASCII. So you do export SGE QPING output format S12, and then you can run that QPING dump, the master, SGE master port, master 1, and you'll actually get a far more detailed output, much longer than we would want to show in this presentation. And this can generate significant overhead, but it could be extremely useful because this will show you the actual detail of the communication packets going between the master and execution daemons. So something that can be useful for debugging, but probably not something you want to turn on for a long time. You can also turn on thread statistics. Again, set up the QMaster params and turn the monitor time to 10 seconds. And do the QPING info, as you see before. And the thread statistics generate quite a lot of data if that interval is short, in 10 seconds. So what will happen is you want to make sure that you disable the logging of the thread statistics to the QMaster messages file. And you just do that by changing the QMaster params and set log monitor message to false, along with the monitor time, the QMaster params. And then that way, you'll get those messages for thread statistics spit out to QPING, but not sent to the QMaster messages file, because that can actually fill up your QMaster messages file with a lot of additional data. Again, this doesn't generate a lot of overhead in the QMaster and can be useful to find out what's going on inside the QMaster in situations where it's slow or seems to go away for a little while. In summary, you can use resource quota sets for fine-grained resource control through quotas for any type of resources. You can use the QMaster read-only thread to significantly improve the throughput and query response times in heavily loaded clusters. There is the option to add synchronized sessions if you need it. You can use GDI request limits, and really it would be quite useful as avoiding denial of service on the QMaster because you can set a maximum per second. And we gave you some idea of what QPING can do, although it can do quite a lot more than what we discussed here. And if you're interested in trying out Untitled Grid Engine, you can get a free demo version at the URL below on our website. You just have to fill in a little form and download the software. All right, I think that's it. Now we have time for questions.
Thank you, Bill. At this time, we would like to open up the presentation to any questions you may have. Please type in your questions into the question pane and we'll address them one at a time. So we have a question here from Frank. Do resource quota sets impact QMaster performance?
Okay. Can you hear me?
Yes, we can.
Okay. Impact on QMaster performance of resource quota sets. Yes, they can have an impact on scheduling times. So it's the scheduler when there's a scheduling run, which has to evaluate the rules. And you can imagine when you configure multiple resource quota set, then the scheduler needs to evaluate all of the rule sets. So the goal should be that you are minimizing the overall number of rule sets. Ideally, you have only one rule set with multiple rules in it. Our recommendation is if you think that the resource quota set evaluation could take too much scheduling time, that you enable the scheduler profiling to watch the impact of the resource quota sets on scheduling times.
Okay, that's great. And another question from John regarding resource quota sets. Does the order of the rules make a difference?
Yes, absolutely. So that was nicely shown in this last example from Bill. So if you are the general approach should be that you are going from the more specific to the more general rules. This example which Bill has shown will be limited a per user per project, and then in the line after we limited per user. So that means in that case the first rule only matched users which requested a project, and then the second rule matched users, well, basically all jobs from users not requesting a project. So this is really important to think about when a matching happens and when not, because you can easily get unexpected results if you're not aware about it.
Okay, we have a question from Ryan. How much additional memory do the read-only threads require?
So we did tests in our lab, and we also got feedback from a couple of customers who run very big grid engine clusters with a big number of jobs, and the feedback was that the read-only threads, when they are enabled, QMaster needs around 30% more memory. From the theoretical consideration, when you have around 2 reader threads, the QMaster memory requirements can be twice as much. This has to do how Grid Engine is handling those requests. When a request comes in, Grid Engine is first packing the data and then sending it over the network. And so there is a short temporary overhead of the packed data until it's sent over the wire to the client.
Okay, thank you. We have another question here. I have a small cluster. Should I disable read-only threads?
So first I should say the read-only threads, you will only see a performance improvement when you really have a big and a loaded cluster, or you have a pretty dated slow QMaster machine. For normal clusters, you wouldn't see any differences. However, when you have big cluster with high throughput, big number of jobs, they are really helpful. So that means you can disable them. There is one advantage, even to use read-only threads in smaller clusters when you have server-side JSVs and you have the need to call qstat or commands from within the server-side JSV. This is absolutely no-go when in Universal Grid Engine 8.1 and when there are no read-only threads, because you can easily create a deadlock when you do a QStat from within a server-side JSV. You can imagine it goes to one of the worker threads, which we mentioned in the webinar. And since there is only a limited number of worker threads, and especially the worker thread needs the so-called global lock, the risk is very high that you would have a deadlock. So QStats from within a server-side JSV are a no-go without reader threads. With reader threads, if needed, they can be done.
Okay, we have a question here from Rob. How much overhead to additional and more complex resource quotas add to the QMaster? Is there a difference in the performance of them between the 8.1x and 8.2x versions?
So regards the overhead, I hope I answered the question. If not, then we can follow up separately. Regards the difference, so generally there is no difference. So we made not major changes to the resource quota set call. So the overhead or the performance in 8.1 and 8.2 should be about the same.
Okay. And then we have another one from John. What happens when a GDI rule is violated?
So when the GDI rule is violated, so that, well, actually it's not violated. I guess the question is about the GDI request limits. So this is a limit, not a quota like in the resource quota. It's a limit per second. So when a user is creating a script where the user is, for instance, doing constantly QStats, and somehow the user forgot to have a sleep in between, so that can hammer the the limit can get exceeded, and then the request is simply not handled, and the client command, the QStat command, the QHost command would fail.
Okay, a question from Rafaela. What happens when a QStat request cannot be satisfied because of GDI limits?
Yeah, so very similar question, I believe. The request is not handled.
Okay, and what kind of message does the user get?
It's the QStat command will exit with a non-zero exit state.
Okay, another one from John. Why were resource quota sets created? Was there a lack of control in the original parameters in Grid Engine?
So, sorry, can you repeat the question, please, Anne?
Why were resource quota sets created? Was there a lack of control in the original parameters in Grid Engine?
Okay, so I believe Bill mentioned it in the webinar. So the resource quota sets are actually a feature which exists since 7 or 8 years in Grid Engine. And simply it's because when you imagine, so we have the scheduling policies, so the shared tree policy, the functional policy, the urgency policies, and so on. All of these policies are targeted that you get the order of the pending jobs right, so that you prioritize which users, which projects get access to the cluster. However, with the scheduling policies, you are not setting a upper limit to what users, projects, and so on can use. And so this need to set hard upper limits is delivered with the resource quota sets. And the reason why we, touch this topic here in this webinar is because, when we talk with customers or when we do the Grid Engine administrator trainings, we see that we have some of the users are really heavily using them. We see very complex resource quota set rules at our customer sites where there are dozens of lines. From the other side, we have users, who are, not really, who are a little bit shy to use them. And the idea was here to show you, they are really easy to use once you get the idea. And yeah, resource quota sets are the means in Grid Engine to set hard upper limits on running jobs in Grid Engine.
Okay, one more final question. What is the best way to apply total memory limits to a group? H_vmem is per job. Can a resource quota set now handle this similar to slots?
Yes, it can. Actually, I had it in the first draft of we had it in the first draft of this webinar. Yes, you can do it. When you, for instance, said if you recall about how it looked, in the end we had limit 2 slots equals whatever. If you do a limit, say 2 HVMem equals, I don't know, 1 terabyte, let's say, or 100 gigabyte, it would mean that those units who are restricted, let's say a specific user, that the sum of all jobs the user runs may not exceed 100 gigabyte, for instance. It's important here to understand that, of course, a limit only can apply when the user has requested that resource. The resource that's not like a consumable resource, it indirectly becomes a kind of a consumable resource when you use it in a resource quota set. Still, the user would have to request it. But for instance, when you think about the job classes, which we have in Univar Grid Engine since 8.1, or when you think about job submission verifiers, so you have many means, of course, that you force your users that they are requesting memory. So indeed, good question. Resource quota sets are a nice means to set upper limits on memory consumption for a bunch of jobs from a user, from a project, and so on.
Alrighty, thank you, Andy, and thank you, Bill. That concludes our webinar today, and we'd like to thank you again for attending. The webinar will be made available for download next week. Be sure to visit our website at univar.com to keep informed of all upcoming news and events. We are currently offering Grid Engine training in San Jose, California, and our next big event will be Supercomputing in New Orleans. We'll be in booth 2115, so please remember to stop in and say hello. If you have any additional questions regarding today's webinar, please email us at sales@univar.com, as we always like to hear from you. On behalf of all the staff here at Univar, we wish you all a fantastic day.